Hi everybody, I'm Jeremiah Blanchard, and I'm going to talk to you about libraries. So in computing, a library is a collection of implementations like classes or functions, usually provided by someone else that we can incorporate into our program. Typically, libraries are contained in a single file, and these can have lots of different extensions. And they may have standardized interfaces for one or more languages. When you're working in a systems language like C++, usually that means you need to use an alternative output when you do the linking. And libraries are usually accompanied by declarations, that is, in C++ or similar languages, header files. What libraries do is they let us bundle functions to extend or go beyond standard components, or what's part of the standard library. So for example, we might have two C++ files, matrix.cpp and morpheus.cpp. We'd compile those into object files, and if we so desired, we could compile them into a library file, kungfu.a. This library could then be incorporated into other programs later on. For example, maybe we take neo.cpp, we compile it into an object file, and then we link our library with our new object file to create our executable, spoon.exe. There are a lot of libraries out there, and so one question you'll have to ask is it actually worth it for me to grab a library and incorporate it into my program? In many cases, we don't actually get to see the code itself, and this depends on the license and the implementation, and that means that the code may be of uncertain quality. Each library also has its own style and functions, and that means there's more to learn. On top of this, it needs to be installed, integrated into the project, and linked, and this is not a trivial process. If you're building something multi-platform, there's probably a different version for every platform, and even typically for every different compiler. Now, with all that said, libraries often make sense, but it's easy to drown in the complexity, so it's worth it to take the time to consider whether a library is worth it before you add that library to your project. The first step in using libraries is to install them, and if you're lucky, this will go easily. Sometimes you can just install a library and it just works. If you're on a system like Ubuntu, you could use the apt utility to install the SFML library, for example. And sometimes you can find comparable utilities on other operating systems. For example, the Chocolatey application does something similar on Windows. You may find that you can just download and run an installer, and suddenly everything works. But most of the time, even if it's the easy route, there are going to be a couple of extra steps. You have to download and extract some archive file, you have to edit the environment variables and mark the location of the folder, and you may have to add a path to your build files like your make file or your cmakelist.txt file or whatever is appropriate for your particular application. Unfortunately, it's not always that easy, and a lot of times there are extra steps. For example, there might be many versions of this library. One for 32-bit OSs, one for 64-bit OSs, one for different compilers, for different compiler versions. You might have to decide whether you want to get the source and build it yourself, or to get pre-built binaries. Then after all that, you have to download and extract the archive somewhere, and maybe you have to run an installer or a command line interface using a Python command. And then you realize you don't have Python, and so you install Python. And then you run the installation command again, and then you realize you didn't have the right version of Python. Oh, you downloaded the newest version? Well, maybe that's your mistake right there. And there's a life lesson for you. Newer is not better, newer is not best, new is just new. And sometimes new means broken. Oh, but we're not actually done, there could be more. So maybe then we go back to the documentation and we read which version of Python we need. And then we install that version, which means we have to download it and run the installer and so on and so forth. Then maybe we realize we can't have the old version and the new version installed if this is going to work. And so we uninstall the new one, and then we go back to whatever step and we start again, and maybe then we have success. And this is just one example of what we call a dependency, which is something that your program or library needs to function. In this case, we used Python as the dependency, but there could be any number of dependencies, and this could still apply. A library that you're trying to use may itself depend on another library, which may depend on another library, and so on and so forth. So, let's say that you've successfully installed your library and gotten it set up. Now you need to add it to your project, and maybe this goes easily, and you add the library name to your build files, and everything just works. Here's a nice example for SFML using a CMake file. We create our project, we set up the SFML directory, we tell CMake to find the packages that we need, and then we add our executable, and we tell it to link to the SFML libraries. But just like with the installation, adding the library to your project may not be as simple as you hope it is. You might need to figure out which library files, like .a files or .lib files, and which headers, .h files, we need. We may need to add the path of those library files and headers, and then we might need to add those file names to the project build files, and then maybe everything will work. But if you have multiple projects, you might have to add it to the first project, and to the second project, and then to a third project, and you may have other dependencies you have to work through as well. So let's say that you've installed the library, you've successfully added it to the project. Now what? Well, now you have to figure out which header files you need. What do you need to include? These are kind of like the table of contents, and they indicate what is in the libraries that we've referenced. Surprise, header files aren't just for irritating students. How about the namespaces for those headers? Especially in modern C++, we'll find that libraries typically use namespaces. What classes or functions are in those namespaces? What does it provide? Not every API is created equally. Some of them are really easy to use and they have good documentation, and other ones, not so much. But the critical pieces are just like any other program. We include a header for the compiler itself. And the library file, a lib or .a file or something else, contains the definition that's used when linking the program. All of this is to say that setup is a necessary evil whenever you're working with libraries. The initial setup of a project or a toolchain is nearly always a pain. This is unavoidable. We can't run away from this. It's something we have to do when we're developing. And while some tools are better than others, they all have tasks that we need to complete. Sometimes the tools just work, and it's glorious. Other times we just got to deal with it. We have to download another update, another driver, update a dependency. And we do get better at this as we do it more frequently, so please don't despair. Every tool has its quirks. So how do you know if it works? Well, does it compile? Does it do the thing you wanted it to do? That's really how we test these things most of the time. But let me make a plea to you. Please, read the docs. No, really, read them carefully. Then read them again. Libraries and toolchains are complex, and if you miss one thing, you might end up wasting hours, so it's better to do a proper read-through the first time to save us from our own stupidity.